Hello and welcome back. This is a completion of the last video on finding the length of the longest common subsequence when we are given two words. So yeah, I took my time to draw out the table. So let's just round up with that example. So we have the two words. Let's call this part I. Let's call this side ij. And we are going to be using this formula to fill up this table, and you're going to see how it makes our work so much easier. When this word, when there is nothing left, you would have 0, no, nothing common. And for this word, when there is nothing here for the j's, you would have 0. These are just the base cases. Then after the base cases, we start to use this formula. If remember, we have two formulas here, one for when the last alphabets are the same, the other one for when the alphabets are not the same. So we have the first consideration here is a and b. A and b are not the same, so we are going to go with this formula. What does this formula say? We want to find pick the maximum between these two. So let's call this position 1, right? So let's say let's call this position 0, 1, 2, 3, 4, 5, 6, 7. And let's call this position to 0, 1, 2, 3, 4, 5, 6. All right. So this cell we're trying to fill is at 1, 1. Is at 1, 1. So we want to fill 1, 1. But to fill 1, 1, we want to find the maximum between this 1, 1 is a Cij, because that's what we want to fill. So we want to find the maximum between Cij minus 1, that's 1, 0, and I minus 1, that's 0, comma 1. So we want to find 1, 0, which is here, 1, 0, and 0, 1, that's here and here. So we want to find the maximum, and in this case they are both 0, so this is 0. A and D are still the same case as this, so we want to find the maximum between this and this, and they are still 0, so we go with that. So A and C still the same case, not equal, so we use the maximum between. I hope this is super clear. Let's take that example again. A and C is at, this is at 1, 3. So I want to fill 1, 3, right? Oh no. This is 1, 3. And to fill it, I want the maximum of I, comma j minus 1. That's 1, 2. And I minus 1. That's 0. And j, 3. 0 and 3. So let's look for cell 1, 2. Cell 1, 2 will be this AD here, and cell 0, 3 would be 0, 3, this one. So what's the maximum? They are both 0, so we still go with 0. A and A are the same, so we go with this. So this is I minus 1, comma j minus 1, whatever we have there, plus 1. And what we have there is 0, so plus 1 is 1. A and B not the same, so we want the maximum between this and this, which is 1. A and A not the same. Oh, they're the same, yeah. So this is 1, 2. So we keep moving. B and B the same. B and D not the same, but the maximum is 1. B and C not the same, but the maximum between this and this 1. B and A not the same, but the maximum still 1. B and B the same, so we add 1 to this point where we have 1. So we have 1 plus 1, that's 2. And B and A not the same, maximum 2. So we are going to keep doing that. C and B not the same, maximum 1. not the same, 1, the same, 2, because I have 1 here, plus 1, 2. Not the same, but maximum now is 2. Maximum of these two values. Not the same, maximum still 2. Not the same, maximum still 2. So we are going to keep, yes, we are going to keep doing this. Oh no, this is 2, maximum is 2. BA, maximum is still 2. BB, that's 3 now. Maximum is 3. So we're going to keep doing this until we fill up the table. Please take your time, fill up the table. And we see that greatest value will be 4. And that will be at this point. This is the point where we have the greatest length for the longest common subsequence. So the greatest is 4. And if you will, just from this table, you can find out exactly what the longest common subsequence is by following the arrow from this position of our answer. I'll be ending this video here. On the next videos, we'll still be taking some examples based on the 01 knapsack problem, which we are currently working on right now. If you like this video, please remember to subscribe. It's totally free. See you on the next one.